Hello. I think I'm live now. Thank you. Thank you so much, everyone who's joining. And for this week, it's a special week because I'm going back to the streaming. Um, so I'm very excited because I'm getting back to that. And for this session, I was thinking that it might be very interesting to talk a little bit about hierarchical forecast because it has a lot of applications. And at least at Nixla, we recently released a new version of our library, hierarchical forecast. So it can be very interesting to play around hierarchical forecast. I didn't prepare a specific data set for this session. Basically, I'm gonna start from scratch. I have just the idea to do something related to hierarchical forecast, but I need to look for a specific data set and then the models that I want to use and so on. So I'm going to start with some context regarding hierarchical forecast. I think that's important, and I'm gonna use the amazing book by professors Rob Hyman and George Atasanopoulos, Forecasting Principles and Practice. It's a very cool book, and I think it exposes very well the hierarchical forecast topic. In fact, I learned all about hierarchical forecast. All I know about hierarchical forecast in this book. So it's amazing. Like it's the book to learn about forecasting and also to learn about hierarchical forecast specifically. So it's an amazing book, and it has different chapters, and in particular it has a chapter for hierarchical forecasting. And this topic it's very interesting and it's pretty important because it has a lot of applications. So the main problem in hierarchical and grouped time series is that you have different time series. For example, you can think on products in the case of retail, and then you want to generate a forecast for all the products that you have, right? But what happens if you also want forecast for some aggregations? We can think about, for example, families of products. I don't know, for example, bread or something like that. And you have like different categories, and also you want to generate a general forecast for that specific category. So how you create those time series? You can basically aggregate the time series that belong to the specific category, and then you will have the time series for your specific category. So then you will have the series of the categories, but also the individual products. And obviously you want to make decisions for the specific products, but also for the categories. So you need forecast for the categories, but also for the products, right? So the main problem in hierarchical forecast is that obviously the forecasts need to be coherent, in the sense that if we sum up the products in the category, we will have the value corresponding to that category. But in the case of forecasting, it usually doesn't apply, because you can have a forecast for the particular products, and then you sum up the products to have the forecast of the specific category, but that doesn't necessarily match with the forecast of the complete category. So how we that's basically an intuition behind a hierarchical time series. In this case, we have an example. You can think in this example, the bottom circles are as the products. Then you have, for example, category A and category B, and then you have the total. And basically, you are summing up the elements in the bottom of the diagram to get the values of the upper categories. In this case, we have an example of Australian tourism hierarchy, and basically we have Australia, and we have the states of Australia. So in this particular example, as you can see, we are exploring Australian tourism, and we have the tourism for different states, and also the aggregated one. And how we ensure that the forecasts are coherent. There are different approaches. Here in this book, there are several approaches that are discussed. For example, the bottom-up approach. In the bottom-up approach, you basically don't forecast the upper levels. You just forecast the lower levels, the individual levels, and then with the forecast of those levels, you generate forecast for the upper levels just by adding the forecast up. And we have also the top-down approach, which is basically the opposite of the bottom-up strategy. Basically, you forecast the top levels, and then you disaggregate the forecast of those levels, following different rules to generate forecast for the bottom levels. Here are discussed different ways to do that disaggregation. And we also have the middle out approach that basically combines those two techniques. Instead of forecasting the bottom level or the top level, you are forecasting the middle level, and then you generate forecast for the upper level using a bottom-up approach and a top-down approach for the bottom levels. And obviously, there are more generic ways to do forecast reconciliation, which is basically the process to make the forecast coherent. And usually in hierarchical forecast, one of the approaches is to do it in a two-step fashion. In the first step, you basically generate a forecast for all the time series in your tree, in your hierarchy. In the example of retail, you generate forecast for the products, but also for the categories, and also for the total demand. Let's say. And then once you have those forecasts, then you apply some reconciliation techniques to make them coherent. And that's the idea behind forecast reconciliation and behind hierarchical forecast. So I'm gonna see if I can provide an example here, but maybe we can take a look to our library, and basically at Nixla we have different ways to do that reconciliation, using those different strategies, right? So that's the main task. Here we also have like an introduction. Let me just show you a more concrete example, just to motivate a little bit this topic. And here, for example, in the case of the Australian domestic tourism, we have the tourism of Australia, but also we have tourism for the time series for different ways of spending that time doing tourism, and also segregated by region. So the main goal of this particular notebook is to generate a coherent forecast across all hierarchies. So basically here, for example, we end up with a coherent forecast using different methods. So basically that's to motivate a little bit this particular project. I think it will be done in 2 steps. The first one will be to clean up the data. I mean, the 0 step would be to select the data set, and after that clean it up a little bit to prepare it to create forecasts. So the first part is more related to setting up the project in GitHub and so on, and after that we will be ready to create the forecast. So let's go to the data set. Let me electricity demand API. A couple of days ago, I guess, I was seeing that we can have a hierarchical data set from the electricity demand space, and I saw that you can collect that data using an API. So basically you can select the root and yeah, different things, and then you can use this API. Let me see if that works. And I think we can use this data because it is segregated by region. So basically we can generate forecast by region. I was thinking about that, but I'm not sure if we can use that specific data. Let me check. Okay. Maybe we can use this one. Includes monthly generation by field type, sector, and state. No, I think it was the first one that I saw. I'm gonna be exploring a little bit right now before start coding to see if I can use this API or another API. We can have data from January to okay. What happens if we do this? Oh my god. And can I download this data or something like that? Let's see the API documentation. JSON data points. Oh my god. Oh my god. Oh no, I think I can use this dataset because I need to register myself, and oh my god. First name, last name, email, category, reason to use this API. Let's read the API terms of service. I'm not sure if I. No, I think I can use this API to collect data. Okay, so I'm gonna fill out this thing. Just 1 minute, please. Video. No, the other one. Okay, nice. So let's fill out this thing. Okay. The reason is educational, because I'm gonna learn in this streaming. Thank you for registering. Okay, oh my god. Let's see if I got my API key. That could be incredibly helpful. So let's see if I can get the API key. That would be amazing. That would be amazing, because that way I can start coding, which is the main purpose of this stream. Oh my god. Oh no. I need to verify my email. So it's being verified right now. Let's see if it works. Hopefully it will work. Hopefully. Oh my god, verification success. Oh my god, I'm so excited. Your API key will be sent to your email address. Okay. Okay, I have my API key. I'm so happy about this. Okay, now I'm gonna put right now that, but I need my, okay. I'm gonna pause the usage of the API key, because I need to create the GitHub repository, and also I need to create the environment file to add the API key. Okay, so I'm gonna do that, and for that I don't need okay, I don't, oh my god, yeah, so I think I can share my screen now, but I'm gonna open my template to create Python projects, because I have a template for creating Python projects. It's not the best template, but it works, which it's good, right? It's good. Where is it? I need to find it. Okay, I have it here. Okay, now let's share. Oh my god, I'm gonna increase the size of this thing. So basically I have this Python project template. Basically uses UV and different things, and it has tests and so on. So I'm gonna use this template, because that's how templates work. So create a new repository. Oh my god. Repository name. What's the best name for this? Okay. So we want to show an application on hierarchical forecast, right? Okay. And we are using electricity demand, right? Select route. State specific data. No, but I think I need to decide first the data set, because data type, it's because, for example, if we select supply and disposition of electricity in state specific data, we will be having data with annual frequency. I mean, we can use annual frequency. I mean, why not? Why not? Okay. Maybe there's another one more interesting. Okay, electricity power operations. It sounds interesting because we can select daily or hourly. Okay, daily demand by subregion, daily generation by energy source. We can select, for example, oh my god, I love this one. Hourly demand by subregion because it's hourly, so it's high frequent. It has high frequency. It's high frequency data. This okay, and okay. This is pretty interesting because we have electricity hourly demand by subregion. We have different for each parent. We have subcategories. I mean, I want to understand the columns just before taking the decision. I'm pretty confident that this dataset can work because I'm seeing that it has like an upper category, in this case the state, from what I see, and it has subcategories as well, so we can generate forecast for these subcategories for the states and also for the whole country. So I think it's interesting. Okay, data type. Yeah, I think I can use this data set. Just let me check. Okay, I understand the query and the things, the query, the API request and those things, but I'm trying to look for some explanation regarding the output. Mm, okay. This is interesting. This is very interesting. Okay, I mean, I think this is going to be easy because we will ask ChatGPT to do the heavy lifting regarding the API. Okay, I want to read the. What are the outputs? Okay, electricity. Then we have electricity power operations, right? It includes forecast demand. Uh, Maybe we can use capability because includes monthly generator level capability by fuel type, sector, and state. Let's see if we can explore this one. I mean, I'm not understanding this pretty well. Because we have electricity, right? So I'm guessing that this is the first root, electricity. Then we have these 4 subsections. So I'm guessing, no, I think it's different, right? What we have balancing authority areas. capability, retail sales. Let's see, capability, inventory. No, I think this is more like. Okay. Alright, let's explore this one. No, my God. I thought that. Oh my God, no! I thought that it was going to open the explanation of the data. No, that's so sad. Okay, okay, okay. Understood. Understood. So let's use this one. But then what? So how can I? How can I see? How can I see the explanation of the outputs? Or let's explore the chart data. Okay, it's loading. Maybe we could wait a little bit for this. No, it doesn't work. I mean, it's pretty fast, to be honest. Okay. Yes, I think I need to explore the response to see if we have more information. Okay, it seems interesting. It seems interesting. Okay. Then I'm gonna create the repository. Okay. Let's see hierarchical electricity hierarchical forecast. Oh my God, this is so exciting. This is so exciting. It's gonna be public and hierarchical forecast application to electricity. It's what kind of electricity, Dana? Electricity. I mean, we have different. Okay, so we have. No. Because we have daily demand forecast generation. Okay. I need to select hourly demand by region. By energy source. I'm just exploring again this datum. Submit. Okay. This is the one that we had before. And we have like day ahead demand forecast and so on, but we will be using Hourly demand by subregion rate. That's the one that we want to use. Yes, exactly this one. Okay. To electricity to hourly electricity demand by sub-region. And we are ready. Okay. And we can... No! What happened? Oh my god. No, I lost the quote. No, this one, right? Hourly demand. Okay. From yeah. ¿Cómo se hace esto? Okay. Create repository. Oh my god. We're making progress. We're making progress. We are creating a new repository, so that's always good. We are on the right direction. So let me clone this amazing repo that we just created, and let me check the pipe project file just to see, okay, the name of the library. We need to change the name of the library. In this case, it's gonna be electricity here. Electricity hierarchical forecast. Let's forecast. Okay. Oh my god. Forecast. Okay. And then what? Then I'm gonna store my API key in my environment file. So I'm gonna pause my screen sharing, and then okay, the name will be okay. And obviously we need to create a .env.example because it's a good practice. It's a good practice. Okay. And then I can share my screen again. Oh my god. And nice. So okay, we've done that. What else do we need to do? We need to follow the, obviously. I'm gonna start a new teamwork session because that's always important. Okay, then we need to follow the instructions in our README. Oh my god. UV, I hope to have it installed right now. But let's see what happens. Let's see what happens if I use this line. Okay. And then we can use that. Okay. Okay, we have our libraries installed, which are the basic ones. Requirements. Okay. Okay, let's add this. I commit a lot. Add init. Okay, and let's push, because I like to push. Okay. So the first thing we need to do is just basically generate a Python script to download this data. For this project, I think I'm not gonna use a database. I'm just gonna download the data, process it, and then write it in local. I'm gonna be persisting the data on my local system, and then I can read the data from it, and we can play with the data. But the first step is to download the data. If we can end this particular stream downloading the data, that would be amazing. A dream come true for me, because I think we will be making progress, and then we can plan the future based on that, right? So I think we can do it. Let's do it. So I'm gonna use LLMs to do that, because I think it's interesting, and it helped. It helps a lot. So okay. So basically, let's submit. I think it's gonna be pretty. Oh, I need to connect to my laptop. Okay. Probably this is going to be straightforward, but let's see. What happens if I just try this API? Oh my god. Okay. How to make requests to the AI.cop API, considering the roots electricity. We have electricity. We also have electricity, power operations, hourly demand by sub-region. Let's change this prompt a little bit. Create a Python script to download data from I want to save the data in a pandas data frame. Include formatting the output of the API. Okay, let's see if this works. Here's Python script. Okay, oh my god. Oh my god, this is amazing. Okay. I mean, it's amazing because it's pretty similar to the thing that we had previously in this one. So basically, yeah, we have the same one. Okay. So I think we can use this. Do we have python.env? No, we don't have it. So I'm gonna install python.env. Oh my god. And I'm installing python.env because I want to read from my environment variable called .env. So basically, I'm gonna invoke that library to read from that file. And we are going to see how to do that in a minute once I install the new library. I mean, no, I think it's Oh my god. What's happening? Okay, perfect. So now we have the CRC thing, right? Okay, so let's go to CRC. We have main here, but my awesome function. Oh my god. Oh my god. So let's create a new module called um, download data. Okay, and just let's copy and paste because this is amazing. Okay. Let's go to 0 and we need to replace our API key. Okay, is the same root? Let's just say let's just check. B2 electricity, it's not the same. It's not the same. I'm pretty sad. I mean, we can like replicate the exact same query. I'm sorry, API call. I want to put some music. I want to listen to some music, but I'm not sure I can do that because yeah, I don't know. Okay, so our API key pandas requests. Okay, so let's exactly. Oh my god, we are connected. We are connected. The LLM and I are one and one self. Okay, so API key. Okay, let's import. Yes. It's getemp, right? Getemp. Exactly that. The base URL, I'm not going to change that. And what do we need? We need the frequency, which in this case is hourly. Before that, no. Okay. We need the frequency. We need data 0 equals to value. That's okay. Then we have sort 0 column period. Okay. And then direction. Okay, perfect. I don't have a problem with that because it's only the direction of the data. In this case, it's descending, but I don't have a problem to have it ascending. And then we have offset 0, and then we have length. Perfect. I'm not going to adjust that. We don't need this one. We don't need this one because we are collecting everything. But what happens if I say length? We're ignoring the length because we want to download everything. Let's see what happens. I'm just exploring here. I mean, I don't have all the answers. Okay. I mean, I need to also change the formatting, but let's wait to Roof to do that work. Okay, so we're trying with the params. Okay, raise for status. Okay, response data. Okay. I think I'm gonna include all of the columns. I mean, I think. No, what's happening here? I mean, we want all the. We want all the columns, right? So maybe we can ignore this part, because for each record, I think we can do this. I think. I'm not sure. I'm just guessing. Let's. I mean, we need to change this one. Period. Okay. Period. Do we need that UTC suggestion? I'm not sure. Let's see what happens. Let's see what happens, because it's important, right? It's important to explore. Just to make a test, I'm gonna add the length parameter. Length, just to see if it works. And if it works, we can try to save that. Try to. Oh my god, this is going to. Okay, so if exactly that. Oh my god. I need to format this thing. Oh my god! No, I thought that I didn't install the pre-commit. Oh my god, this is no. Okay. This is not good. Now it's installed. I'm gonna add a change. I think I can use roof format. Roof format. Okay, because I want it to be pretty. Oh my god! And I have an integration to do it directly on Beam, but the main problem is that it doesn't work, and I haven't had enough time to fix that problem. But I'm working on that. Okay, so import requests, import OS, import pandas. So I think we can test this short module. I always like to call my Python code using module. Oh my god! I always forget that request is not first party. This is going to be changed by our pre-commit, but I need to install. Okay. Oh my god. Oh my god. We need also pandas. Oh my god. This is pretty cool. It worked. Okay. So now what? Now download data, and then what we can do. I mean, we need to remove that index because I don't like that index. And then And then I think we are ready to save the data set and exploring it. I'm just gonna print the info. Okay. I'm gonna save the dataset because I want to explore it. And obviously, since I want to explore it, I need to use Jupyter Lab. I could use Visual Studio. Okay. Well, I think it works right. Okay. What I'm thinking is that I can explore the data in the next session to start with that, and if there are errors, I can modify the pipeline. So the only thing I'm gonna do is just finish this thing by saving the data. And for that, I'm gonna use fire. Let's get started. Fire. Why I'm going to use fire? Because I want to pass an extra parameter. Maybe I can. I don't know. Fetch data. Save. I'm thinking about what's the best way to save this data. I mean, what we can do, just to make it okay, I'm gonna save it as Parquet file, and what I'm going to do is name it why Parquet file, because I want to persist. I want it to be small, the size of the data, and I also want to persist this to datetime operation, because if I save the data in a CSV file, I'm gonna need to reconvert this column again. So, and the name again. We have